Good morning once again. Our next topic is thermodynamics. Hope you have studied this chapter at high school level. You know some basic concept. However, let me explain some basic concept before we go in detail. Thermodynamics. So, here thermo means heat, dynamics, motion. So you can say that thermodynamic means study of flow of heat. Study of flow of heat. You know that most of the processes are taking place in the presence of heat. So when we heat something, there are many processes are taking place. So thermodynamic is dealing with study of flow of heat. The word thermodynamic implies flow of heat. It deals with energy changes accompanying by all types of physical and chemical process. So due to heat, how chemical and physical processes are taking place, that one you can understand more by thermodynamics. Thermodynamics is based on two generalizations called the first law of thermodynamics and second law of thermodynamics. These are based on the human experience, but there are some limitations. So thermodynamics we cannot study by taking little amount. For example, micro quantity. For example, when we want to study, when we heat water, we can't take 1 ml of water or 2 ml of water. So when we heat 1 ml or 2 ml of water, when we heat, what happens? It evaporates very fast. So we need to take a bulky quantity. So we can say that thermodynamic is dealing with the macroscopic properties. See, limitation. Thermodynamic is applicable to macroscopic system consisting of matter in bulk and not to microscopic system of individual atom or molecule. It ignores the internal structure of atoms and molecules. Thermodynamics does not bother about the time factor. That is, it doesn't tell anything regarding the rate of a physical change or a chemical reaction. It is concerned only with the initial and the final state of the system. It is dealing only with the initial and final state of the system. For example, when we heat water and we study only at the end of the stage, means at the final heat, what chemical and physical processes are taking place. That is, it is concerned only with the initial and the final states of the system. The scope of thermodynamics, most of the important laws of physical chemistry, including the Van der law, lowering of vapor pressure, phase rule, and the distribution law, can be derived from the law of thermodynamics. It tells whether a particular physical or chemical change can occur under a given set of conditions of temperature, pressure, and concentration. It also helps in predicting how far a physical or chemical change can proceed until the chemical conditions are established. There are some basic concepts. We must know what is system, what is the surrounding, what is boundary, etc. First, system. A system is defined as any specified portion of matter under study which is separated from the rest of the universe with the bounding surface. A system may consist of one or more substance. For example, we want to take water. You want to heat it. Heating. So here the water is a matter. Water is a matter. This is called system. This is called system. So this is system. So a system is defined as any specified portion of matter under study which is separate from the rest of the universe, that is called surrounding with a bounding surface. So this is surrounding. So this is a boundary which separates the system from the surrounding. So a system is defined as any specific portion of matter under study which is separated from the rest of the universe with a bounding surface. A system may consist of one or more substance surrounding. What is surrounding? The rest of the universe, which might be in a position to exchange energy and matter with the system, is called surrounding. So when we study about a system, the surrounding also play an important role. For example, when we heat water, it boils at 100 degrees Celsius in the Earth atmosphere, at 1 atmosphere pressure. Same time means it boils at 100 degrees Celsius. If we take same amount of water, we go to moon and we want heat, the temperature will be different, gas pressure is different. So the surrounding plays an important role for studying a system. Now there are different types of system. System is open system, closed system, and isolated system. First we take open system. What is open system? A system which can exchange matter as well as energy with its surrounding is called open system. For example, take a beaker having water and we are going to heat. Well, this is a burner, we are going to heat. Imagine that this is not closed. So take a beaker and have some water and heat it. Since it's open, what happens when we heat? It produces heat and it starts to evaporate. So what happens? A system which can exchange matter as well as energy. So what is happening here? The energy, heat energy, it produces heat energy. At the same time, the matter, the water also escapes. So both energy, the heat energy as well as matter, the water evaporates. So in open system, both energy and matter exchange with the surrounding. That is called open system. That is both energy and matter both exchange with the surrounding. A system which can exchange matter as well as energy with the surrounding is called open system. Now, let us take closed system. What is closed system? A system which can exchange energy but not matter with its surrounding is called closed system. Let us consider a beaker having water. This water is a matter. It is covered with lid. And when we heat, what happens? It produces heat energy. So when we go near to our beaker, you can feel hot. Why? It exchanges its energy, heat energy with its surrounding. However, it can't exchange its matter. Why? Since it is closed, the matter when it evaporates, the water when it evaporates, it can't escape because it is closed. That is the reason in a closed system, only energy can transfer with the surrounding, not matter. Next one is isolated system. What is isolated system? A system which can exchange neither energy nor matter. For example, you can take thermos flask. You know thermos flask? For example, when you study whole night you need some hot drinks, some of you drink hot water or some hot milk. What do? You store in a thermos flask. Say the temperature of milk is 80 degree. Even when you open after 6 hours, you can see that the flask is good. You can feel same hot. It maintains hot. So in this case, what happens? The amount of milk as well as the temperature both are maintained. So here neither matter nor energy is exchanging with a surrounding. That is called isolated system. Again, I am repeating that open system. It can exchange both matter as well as energy with its surrounding. Whereas in closed system, since it is closed, it can exchange only energy with surrounding, not matter. Whereas in isolated system, neither energy nor matter exchange with surrounding. Okay, now states of the system. State of the system. When macroscopic properties of system have different value, the system is said to be in different state. When macroscopic property of the system have different value, the system is said to be in a different state. So we can define this one in another way. The fundamental property which determine the state of system are pressure, temperature, volume, mass and composition. Since a change in the magnitude of such property alters the state of the system, these are referred to as state variables, state function or thermodynamic parameter. So we must know that which are state variables: pressure, temperature, volume, mass, composition. These are called state variables. Some common state functions are internal energy, enthalpy, entropy, free energy, pressure, temperature, volume. We know the symbol of pressure P, temperature T, volume V. The internal energy symbol is E, enthalpy, the symbol is H, entropy symbol is S, capital S, free energy symbol is capital G. Okay. Next one is thermodynamic equilibrium state. What is thermodynamic equilibrium state? A system in which the macroscopic properties do not undergo any change with the time is said to be in thermodynamic equilibrium. Or we can say in another way, a system in which the state variables, already know what is state variables. A system in which the state variables have constant value throughout the system is said to be in state of thermodynamic equilibrium. Suppose when a process is undergoing, the variables, that is such as temperature or pressure, have constant throughout the process, then we can say this is thermodynamic equilibrium. Suppose we have a gas confined in a cylinder that has a frictionless piston. Here gas is there. So look at this one. Suppose we have a gas confined in a cylinder that has frictionless piston. The piston is stationary, it's not moving. The piston is stationary. The state of the gas can be specified by giving the value of pressure, volume. The system is then in a state of equilibrium. So we can specify when the piston is stationary. Now, non-equilibrium state. What is non-equilibrium state? A system in which the state variables have different values. Already know what is state variables. The state variables that pressure, temperature, volume, mass, composition, etc. The state variables. A system in which the state variables have different values in different parts of the system is said to be in non-equilibrium state. Now same thing, I am taking non-equilibrium state here. For example, pressure, temperature, volume, etc. are constant. But non-thermodynamic equilibrium takes same thing. The gas is there. The piston. If the gas contained in a cylinder, as stated above, is compressed very rapidly. Now we are moving the piston rapidly. We are moving the piston very rapidly by moving down the system piston. That is the original. This is the original place. Now we are moving downwards. Rapidly we are moving. The final state here. Very fast we are moving. What happened? The gas contained in a cylinder, as stated above, is compressed very rapidly by moving down the piston. It passes through states in which pressure and temperature cannot be specified. Why? Since these properties vary throughout the gas, the gas near the piston is compressed and heated, and that at the far end of the cylinder is not. The gas then would be said to be in non-equilibrium state. So the gas near the piston is compressed and heated, that at the far end of the cylinder is not. Then we can say it's non-equilibrium state. So what is the main difference between equilibrium and non-equilibrium states? In equilibrium state, the piston is not moving, so the pressure, temperature, volume are constant. Even the piston moves slowly also, it can be constant. Whereas non-equilibrium process, same process, when the piston moves rapidly, then the pressure is the gas is compressed very fast, and the state variables, temperature, pressure, volume are not constant. Here, pressure, temperature are not constant. We can say it's non-equilibrium state. Okay, now thermodynamic process. Thermodynamic process and the type. What is thermodynamic process? The operation by which a system changes from one state to another state is called a process. Whenever a system changes from one state to another, it is accompanied by change in energy. There are different types of process: isothermal process, adiabatic process, isobaric process, isochoric process. Now, the first one is isothermal process. What is isothermal process? A process is said to be isothermal if the temperature of the system remains constant. That is, for isothermal process, delta T is constant. So delta T is equal to 0. You must know that isothermal process means the temperature of the system remains constant. For isothermal process, change of temperature is constant, that is equal to 0. Next one is adiabatic process. The process is said to be adiabatic if no heat enters or leaves the system during any step of the process. Again, I am repeating that. For adiabatic process, no heat enters or leaves the system during any step of the process. So, for adiabatic process, delta Q is equal to 0. So T means temperature. Here Q stands for heat. What is it? Q is for heat. So adiabatic process, delta change there is no heat when leaves the system during any step of the process. So delta Q is equal to 0. Next one is isobaric process. The process is said to be isobaric if the pressure of the system remains constant during each step of the process. So for isobaric process, change of pressure is constant. Means what? Delta P is equal to 0. The process is said to be isobaric if the pressure of the system remains constant during each step of the process. For isobaric process, delta P is equal to 0. Next one is isochoric process. Isochoric process, a process is said to be isochoric if the volume of the system remains constant during each step of the process. So for isochoric process, change of volume is constant, that is delta V is equal to 0. A process is said to be isochoric if the volume of the system remains constant during each step of the process. For isochoric process, delta V is equal to 0. Look at this diagram where we draw pressure against volume. So for isobaric process, delta P is equal to constant, and isochoric process, volume remains constant. So again we are repeating that. For isothermal process, delta T is equal to 0. For adiabatic process, delta Q, heat is constant, delta Q is equal to 0. For isobaric process, pressure remains constant, that is delta P is equal to 0. For isochoric process, volume remains constant, that is delta V is equal to 0. So usually students get confused. Again we are repeating that isothermal temperature constant. Adiabatic process, heat, that is delta Q is equal to 0. Isobaric pressure remains constant, delta P is equal to 0. Isochoric, remember volume remains constant, that is delta V is equal to 0. Now reversible and irreversible process. So some processes are reversible and some processes are irreversible. So sometime what happens, the process after finishing again it can reverse. That is called irreversible process. Sometimes the process cannot be reversed. That is called irreversible process. For example, when we burn fuel, what happened? The hydrocarbon burned with oxygen and it became, it is consumed, it can't be brought it back because it is consumed. Some processes are reversed. For example, as I explained, nitrogen reacts with hydrogen to form ammonia. Again, it can bring back. But we can't bring that example here. For example, when we take a spring, when you pull and leave it back, it can come to original state. That is called reversible process. Some processes are irreversible. After the process is over, it cannot bring it back. The process which is carried out infinitesimally slowly in such a manner that the system remains almost in a state of equilibrium at each and every stage, or a process carried out infinitesimally slowly, so that the driving force is only infinitesimally greater than the opposing force is called a reversible process. Again, repeating that, a process which is carried out infinitesimally slowly in such a manner that the system remains almost in a state of equilibrium at every stage, or a process carried out infinitesimally slowly so that the driving force is only infinitesimally greater than the opposing force is called a reversible process. A process which does not take place infinitesimally slowly is said to be irreversible process. Usually, reversible process, the process takes place very slowly, that is infinitesimally slowly. Sometimes the process takes place very fast. It can't take place slowly. They are called irreversible process. In fact, all the natural processes are irreversible process. For example, a big stone, a fall, and we can't bring it back to the original place unless we consume some energy to take it back to the original place. They are called irreversible process. Sometimes disaster take place. They are also irreversible process. So most of the natural processes are irreversible process. For example, a dissolution of salt in water, dissolution of salt in water. For example, when sodium chloride, when you mix with water, it dissociates Na plus and Cl minus. Again, Na plus can combine with Cl minus, give back sodium chloride. It is called reversible process. Even you take oxygen, it is when take oxygen and hydrogen gas to form water. Again, the water can be dissociated, give back oxygen and hydrogen. So when water undergo process called electrolysis process, we can bring back oxygen and hydrogen. So this process also reversible process. Now, okay, we can take one more example: freezing or boiling of water. Now, when we freeze water, what happens? Take water, it's a liquid. When we freeze it at 0 degrees Celsius, it forms what? Ice. That is solid form. When we change temperature, again we can bring back. So this is a reversible process. Same time, when we heat water, what happens? The liquid form of water evaporates into gaseous form, but the component remains same. Again, by changing the temperature, we can bring back the original state. They are all reversible process. Now, example for irreversible process. Now, hydrocarbon combustion, like the burning of wood or oil or radioactive decay, they are irreversible process. For example, fuel. What is fuel? Fuel is what? Alkane. We fill fuel and drive a car or ride bike. What happens? The fuel burns with oxygen. It is and produces energy. It is combustible and it is consumed. We can't bring it back. It is irreversible process. Or you can say radioactive decay. I will discuss more about this radioactive decay when I explain nuclear chemistry. Suppose nuclear fission reaction take place or nuclear fission reaction take place. What happens? It's undergoing decay. We can't bring it back. They are irreversible process. So reversible process, we can bring it back. Irreversible process, we can't bring it back. Okay. Now, the differences between reversible and irreversible process. It takes place in infinite number of infinitesimally small steps, and it would take infinite time to occur. Irreversible process, it is a process which does not take place infinitesimally slowly. It is imaginary, it is real. It is imaginary as it assumes the presence of frictionless and weightless piston. It is real and it can be performed actually. It is in equilibrium state at all stages of operation. it is in equilibrium state only at the initial and final stages of the operation. But other place, other stage, it is not equilibrium. All changes are reversed when the process is carried out in reversible direction. After this type of process has occurred, all changes do not return to the initial state by themselves. It is extremely slowly. It proceeds at measurable speed. Work done by reversible process is greater than the corresponding irreversible process. Work done by an irreversible process is smaller than the corresponding reversible process. So these are the differences between reversible and irreversible process. Okay. Now, next one is internal energy. We know that all matter has some energy to do work. For example, the human being also has some potential energy to do some work. We can compare, for example, babies have different energy, young age person have different energy, and old age person have different energy. So all of us have different kinds of energy to do work. So every substance is associated with a definite amount of energy, which depends upon its chemical nature as well as upon its temperature, pressure, and volume. This energy is known as internal energy. So internal energy of system is energy possessed by all its constituent molecules. So internal energy is a state property. Its value depends only upon the state of substance, but does not depend upon how the state is achieved. So each matter is having different amount of energy. For example, when we take fuel, diesel is having different energy. Fuel like kerosene is different energy. Diesel is having different potential. So all the matters are having different energy to do work. They are called internal energy. Now, macroscopic properties. The properties associated with macroscopic system, that is consisting of large number of particles, are called macroscopic properties. Pressure, volume, temperature, composition, density, etc. are macroscopic properties. Now, extensive and intensive property. What is extensive property? Extensive property of a system is that which depends upon the amount of substance present in the system. For example, you take a beaker. So a beaker is having 10 ml, and another beaker is having 20 ml, another property is having 30 ml. So their mass changes, volume also changes. So they are all called extensive property. Extensive property means it depends upon the amount of substance present in the system. For example, you take one empty cylinder, another one is a cylinder which contains more amount of gas. When we carry, both of them differ. One is the empty cylinder weigh less, whereas the cylinder which contains more amount of gas will be more weight. So who decides the volume? The volume is decides. That is called extensive property, which depends upon the amount of substance present in the system. Now, an intensive property of the system is that which is independent of the amount of substance present in the system. Means this property which doesn't depend upon the amount, that is the quantity of the system. For example, temperature, pressure, density, concentration, viscosity, surface tension, refractive index, etc. are intensive property. For example, you take 1 molar sodium hydroxide solution, from which you take 10 ml separately, or 20 ml separately, or 30 ml separately, or take 1 ml, or you take 1 drop. All of them have same concentration, that is 1 molar. So what I am telling here the properties not depends upon the quantity. That is called intensity property. For example, now we are in this room. Here, say the temperature at this at that corner, say 22 degree. When we move to that place, also same 22 degree, 22 degree. They are called intensity property. It not depends upon the means it's independent of the amount of the system. Sorry, it's independent of the amount of substance. For example, you take pressure. In this room, the pressure remains constant. Whether you go to that corner or the middle or everywhere, the pressure remains constant. Now we take another example. You are walking from one place to another place. The atmospheric pressure remains constant. Maybe one atmosphere at one end. When we move to another end, also same atmosphere. So it is not depends upon the amount. That is, the intensity property of the system is that which is independent of the amount of the substance present in the system. So we must know that temperature, pressure, density, concentration. What is density? For example, you take 1 liter of sulfuric acid. You take 1 ml or 2 ml or 3 ml or 10 ml of sulfuric acid, the density remains constant. So it is independent of the amount of substance. Now we are going to enter into numerical. Before understand about numerical, we must know some basic concepts. Okay. First one is isothermal reversible expansion work of an ideal gas. Now, isothermal reversible expansion work of an ideal gas. Let us consider an ideal gas confined in a cylinder which with a frictionless piston. Suppose it expands in a reversible manner from volume V1 to V2 at a constant temperature, and the pressure of the gas is successfully reduced from V1 to P2. That is, a piston connected in a friction means consider an ideal gas. Here, ideal gas confined in a cylinder with a frictionless piston. Suppose it expands reversibly from a volume V1 to V2. Say so what happens? The volume changes. Volume changes from V1 to V2. The pressure also reduces from P1 to P2. Why? Because it expands reversibly. So what happens? Volume changes and pressure also changes. The formula to find work done is W is equal to minus 2.303 nRT log D2 upon D1. And pressure is W is equal to minus 2.303 nRT log D1 upon D2. That is, so here, what is N? N is number of moles. R is gas constant. T temperature. The V, you know that V is the initial volume. V2 final volume. Pressure also same P1 and P2 change of pressure from initial to final pressure. So here we know that how do we get V1, V2? We know that V1 is equal to P2, V2. Already we studied in gas law. Therefore, V1 upon, or we can write V2 upon V1 is equal to V1 upon V2. So we are getting this relation. Okay. So V2 upon V1 can be written as V1 upon V2. So it's very necessary to be careful that when volume is given, use this formula, and pressure is given, use this formula. Okay. So isothermal reversible expansion work on ideal gas is equal to W is equal to minus 2.393 nRT log V2 upon V1. W is equal to minus 2.393 nRT log P1 upon P2. Suppose we change sign here, then you write plus, then you can write V1 upon V2. Here you write plus, then we can write P2 upon P1. Please don't confuse, follow this method so that you don't get any wrong answer. Now, isothermal irreversible expansion work of an ideal gas. This is isothermal reversible expansion. Reversible. Now, isothermal irreversible expansion of an ideal gas. Remember that it is irreversible. Suppose we have an ideal gas contained in the cylinder piston. This time, the process of expansion of the gas is performed irreversibly. That is by instantaneously dropping an external pressure P ext to the final pressure P2. The work done by the system is now against the pressure P2 throughout the whole expansion and is given by the following expression. Then we can write W is equal to minus P2 V2 minus V1, or we can write W is equal to P2 delta V. Delta V is equal to V2 minus V1. So we can write W is equal to P external delta V. So for isothermal reversible expansion, this formula. Isothermal irreversible expansion, we must use this formula. Next one is first law of thermodynamics. Okay. What is first law of thermodynamics says that energy can be neither created nor destroyed. That is called the first law of thermodynamics. The first law of thermodynamics states that energy can neither be created nor be destroyed, although it can be transformed from one form to another form. But energy can neither be created nor destroyed is called first law of thermodynamics. The mathematical form of first law of thermodynamics is delta E is equal to P plus W. Sometimes we can write delta E as delta U. This is called first law of thermodynamics. Here Q is heat, W is work done, U or E is energy. So this is the first law of thermodynamics. So the mathematical express of first law in general, if in a given process the quantity of heat transferred from the surrounding to the system is Q and work done in the process W, then change in internal energy can be written as delta E is equal to Q plus W or delta E is equal to Q plus W. Note that if work is done by the surrounding on the system, as during the compression of the gas, W is taken as positive, that is delta E is equal to Q plus W. Very, very important. Note, if work done work done by the surrounding, work done by the surrounding on the system, then W is positive. That is delta E is equal to Q plus W, work done by the surrounding. Next, if work done by the system is done by the system on the surrounding, just opposite. Then W is negative. So delta E is equal to Q minus W. So please don't get confused with the formula. Again, I'm repeating that work is done by the surrounding on the system, then W is positive, then delta E is equal to Q plus W. The work is done by the system, done by the system. Work is done by the system on the surrounding, then W is negative, delta E is equal to Q minus W. Okay. Now we need to see the numericals. Already I explained the concept about the first law of thermodynamics and isothermal reversible expansion of ideal gas and isothermal irreversible expansion of ideal gas. So please go through all this formula. Next class we can discuss, we can see numericals. So please study so that when I explain next time, you will be able to understand more about this numerical. Please study well. This is online class, so you need to focus on all these concepts. So very good day. Enjoy your day. Thank you.